सर आवाज नहीं आ रही है।
बिस्मिल्लाहिर्रहमानिर्रहीम, अस्सलाम वालेकुम। मैट टू इंडस्ट्री बूट कैम्प के पाँचवें सेशन है। इसमें आप तमाम पार्टिसिपेंट्स को खुशामदीद कहते हैं। आज का जो हमारा टॉपिक है वो है मैथमेटिकल मॉडलिंग ऑफ कॉम्प्लेक्स मैकेनिकल असेंबलीज। मेरा नाम डॉक्टर मोहम्मद इलियास, असिस्टेंट प्रोफेसर हूँ मैथमेटिकल साइंसेस रिसर्च सेंटर फेडरल उर्दू यूनिवर्सिटी में। हमारा जो आज के स्पीकर हैं प्रोफेसर डॉक्टर तनवीर हुसैन साहब, उनका थोड़ा सा इंट्रोडक्शन कराता चलो। डिपार्टमेंट ऑफ मैकेनिकल इंजीनियरिंग में एज प्रोफेसर काम कर रहे हैं मेहरान यूनिवर्सिटी ऑफ इंजीनियरिंग एंड टेक्नोलॉजी में। आपका जो पीएचडी है वो है यूनिवर्सिटी ऑफ नॉटिंघम, इंग्लैंड। एमएस से आपका मेहरान यूनिवर्सिटी ऑफ इंजीनियरिंग एंड टेक्नोलॉजी से। उसके अलावा जो फील्ड ऑफ एक्सपर्टीज़ हैं वो हैं डॉक्टर साहब के जो है वो स्पेशलाइजेशन इन डिज़ाइन मॉडलिंग एंड एनालिसिस ऑफ मैकेनिकल असेंबलीज, स्टोकास्टिक एंड अनसर्टेनिटी एनालिसिस ऑफ मैकेनिकल,
इलियास साहब आपकी आवाज नहीं आ रही।
अस्सलाम वालेकुम। जी आवाज नहीं आ रही बिल्कुल भी।
हेलो, जी अब आवाज आ रही है?
जी सर।
जी माजरत, डॉक्टर साहब के एक्सपर्टीज के हवाले से बात कर रहा था, स्पेशलाइजेशन इन डिज़ाइन मॉडलिंग एंड एनालिसिस ऑफ मैकेनिकल असेंबलीज, उसके अलावा स्टोकास्टिक एंड अनसर्टेनिटी एनालिसिस ऑफ मैकेनिकल सिस्टम, डेवलपमेंट ऑफ वर्टिकल एक्सिस विंड टर्बाइंस, enhancing charge acceptance and power storage capacity in lead acid batteries. इनके जो वर्क एक्सपीरियंस के हवाले से अगर हम बात करें तो ट्रेनिंग कंसल्टेंट रहे हैं यूनाइटेड एनर्जी पाकिस्तान लिमिटेड में। उसके अलावा एज सीनियर कंसल्टेंट प्लस वेलोसिटी पाकिस्तान में काम किया है। इन्हांसिंग चार्ज एक्सेप्टेंस एंड पावर स्टोरेज कैपेसिटी इन लीड एसिड बैटरीज, जिसके अंदर प्रोजेक्ट पे इन्होंने काम किया है, द प्रोजेक्ट विद रेम्बो हाई टेक इंजीनियरिंग कंपनी प्राइवेट लिमिटेड से। डिज़ाइन एंड मॉडलिंग ऑफ वर्टिकल एक्सिस विंड टर्बाइन, a unique spiral threaded turbine design। उसके अलावा मुख्तलिफ उसमें इन्वॉल्व रहे हैं, जिसमें इंस्पेक्शन ऑफ NTD एंड HDD ऑफ 32 इंच डाया LNG लाइन लेड बिटवीन जामशरो टू नवाबशाह, पावर जनरेशन enhancement and heat rate analysis of Jamshoro thermal power plant, involved in assembly design of jet engine casting rotor at Rolls-Royce PLC UK। उसके अलावा जो है वो डॉक्टर साहब असेंबली डिज़ाइन ऑफ जेट इंजन कास्टिंग विद MTU एरो इंजन GmbH जर्मनी में भी काम कर चुके हैं और करेंटली एज ए प्रोफेसर काम कर रहे हैं मेहरान यूनिवर्सिटी में। डॉक्टर साहब जी जी, डॉक्टर तनवीर हुसैन साहब से मैं गुजारिश करूंगा कि आप अपना स्क्रीन शेयर करें और
इलियास साहब मुझे अगर कोई इनेबल कर ले, क्योंकि
जी जी मैं एक सेकंड,
मुझे डिसेबल किया हुआ है स्क्रीन शेयरिंग के लिए।
जी डॉक्टर साहब अभी आप होस्ट हैं और अपनी स्क्रीन आप शेयर कर लीजिएगा काइंडली।
अब स्क्रीन शेयर हो रही है सबके सामने?
जी सर।
ओके, बिस्मिल्लाहिर्रहमानिर्रहीम। This is Dr. Tanweer Hussain and I'm professor in the Department of Mechanical Engineering, Iran University of Engineering and Technology, Jamshoro. Thank you very much, Ilyas Saab and the whole team for inviting me to give this small topic presentation. I would just simply start with the basic brief about the assembly and then go in depth with the mathematical modeling which is involved in the assembly, mechanical assembly, variation, propagation. डॉक्टर साहब ने मेरा इंट्रोडक्शन करवा लिया एंड आई थिंक कुछ डॉक्टर साहब ने ज़्यादा ही लंबा चौड़ा इंट्रोडक्शन करवा लिया। मैं एक छोटी सी नाचीज़ शख्सियत, एक्चुअली मेरी जो ग्रेजुएशन थी वो मैकेनिकल इंजीनियरिंग में, फिर मास्टर्स मैन्युफैक्चरिंग में, उसके बाद PhD मैंने मैकेनिकल इंजीनियरिंग से ही की और माय journey of career started from Diwan Sugar Mills. फिर मैंने Diwan Motors में काम किया और couple of years, and after joining that फिर मैं मेहरा यूनिवर्सिटी में as a teacher join कर लिया था 2003 January में. Then I left Mehran University again in 2005. I joined E&I gas field, oil and gas field. And I worked there for a particular project of OBM treatment. And then I again joined back Mehran University क्योंकि एक scholarship आई थी, faculty development program, जिसकी basis पे फिर मैं बाहर चला गया, and then I joined back university. So alhamdulillah, it was very nice. I was lucky enough that I got scholarship, और scholarship भी ऐसी थी जिसमें मैं I was free to take course at any university of the world, top ranked university में कहीं पे भी ले सकता था. मेरी जो specialization थी वो एक बचपन से एक motivation थी. While I was just a young boy, a small kid, और मैं by the way family में सबसे छोटा हूँ. ब्रदर्स एंड सिस्टर में तो मुझसे बड़े भाई या उनके जो दोस्त वो पूछते थे कि बड़े होकर क्या बनाओगे, तो मेरा शुरू से एक मेरी इंस्पिरेशन थी कि मैं जहाज बनाऊंगा. बस ये एक बचपन का एक शौक. And I was lucky that while I visited the University of Nottingham to carry out my PhD process, I got a project with my supervisor, which was with the Rolls-Royce company. Rolls-Royce company जो है वो उसका आपने नाम सुना होगा कार के हवाले से. ये Rolls-Royce की कारें, Rolls-Royce की गाड़ियाँ. But actually इनके जो main product है जो जिस की वजह से उनका main business चल रहा है वो बहुत एक costly efficient किस्म की jet engine है, और that is basically the main product of the Rolls-Royce nowadays. And if you look at the news and media, it was early 2007 when there was a plane crash near Burma. And during that plane crash, it was the plane crash of Airbus having A380, which was carrying almost nearly 800 plus people, passengers and the staff. Because of some reasons, the plane crashed. And it was very unfortunate that all the humans who were on board, they could not survive because of this fatal accident. So at that time, the team visited the site and they started looking into the root cause for this particular, accident. And at that particular team, they started investigating the black box recording and other things by looking at different components of the crashed plane. They ultimately came across that the plane crashed because of the engine failure. And engine failure was because of the excessive vibration into the engine. And later on, a team was formed, which started investigating what was the problem in the design of that particular engine and how can we improve that design. So alhamdulillah, I was lucky enough to get into that project, and I was a part of that team. And my main role was to minimize the normally actually we see that the vibration can be caused by two reasons. One is the mass imbalance, and other is geometric eccentricity of the particular jet engine rotor. Because jet engine is simply an engine which have a rotor which contains turbines and compressor all coupled in single shaft. Okay, so it has got HP compressor, then intermediate compressor, LP means low pressure compressor, and similarly it has got low pressure turbine, intermediate pressure turbine, and high pressure turbine. These all are coupled and a single component. And these all are parts which are axially symmetric as well. So I started working onto that design, and I started looking into minimizing the geometric eccentricity which it normally attains during the assembly of different components. This jet engine, complete assembly of jet engine contains more than 400 components. They are connected together in a form of similarly like a disk. They are connected together, and that particular disk, these disks are then assembled so that the whole rotor should be straight on a particular alignment, so that it should not have geometric eccentricity from the ideal axis. So then my journey started over there, and I just redesigned that engine, and the name of the engine was Trent 1000. Earlier to this, the engine Trent 1000, which was designed by the previous team of the Rolls-Royce, was redesigned in 2000, final and redesigned in 2009. So here, looking into the mechanical assembly, if I talk about the jet engine or any particular object, whatever you see, every component which is useful, which is performing any particular operation, is either single component. Very few of the components are single component. Otherwise, most of the parts are assembled part. If you look into this simple assembly of sharpener, which is in front of you onto the screen, if you see, this sharpener is a simple component. In spite it is a simple component, it contains three parts. One is the main housing of the sharpener. Then we have a blade, which helps in sharpening the pencil. Then we have a screw that holds that blade onto the housing of that particular sharpener. Now, without assembling these parts into a proper location, the individual part of the sharpener will be useless unless they do not perform its proper function. Now, if I see, if I ask you, what is the main function of the sharpener? The function of sharpener is to sharpen the pencil lead and enable it so that we can write something onto this. And it should not break that lead, which is the tip of the pencil. So these are the main functions. So the parts which are assembled, they always are assembled in such a way so that the machine or the object should perform its proper function. Even if further look into the very simple assembly, the assembly of an hammer, hathoda jisko kehte hain. This hammer, it includes two parts, hammer head and the handle. Okay. Now, simply, if you see, the hammer would be useless without having both the components together. If you simply take the hammer head, it won't perform the function properly. Or if you only hold the handle, it won't perform the function properly. So we need to combine those two parts so that it starts working properly. So this assembly is basically, when we talk in terms of mechanical engineering perspective, it is the process of putting parts together to perform a desired function, obviously. So this assembly process is inherently integrative, and it requires coordination and combination of various parts. It may require the coordination of other tools, fixtures, people, and other companies as well. Why we say companies? Because there are some complex parts which require parts which are being manufactured at some other plant. I'll just come into that later on into the upcoming slide. So here, if you see, this is the figure of a plane, and in this plane, you can see it has got two wings, and each wing carries two engines. ये जो round किस्म की blower type, you can see, we normally see behind the wings, and I'm also showing through the marker on this slide. These are the wings, and these are the engines, which are is connected with the wing. Now, these wings, these engines, if they stop working at any time while it is in the flight, it is on air. So obviously, it is a huge danger, and it may cause the risk of different lives, several lives. So obviously, here, if you see, these engines are mounted just below the wings, and which propel the whole plane into the sky up to different heights, 35, 45,000 feet, and so on. Okay, so let us see this start again, looking into other assembly of other components. Similarly, there are different assembly lines in the different industries as well. If you look into the simply an industry which starts assembling the parts together from, so they, what do? They first of all collect the parts from different locations. Either they do manufacture locally, or they purchase from the other vendors or other suppliers or other industries. So they you can see this small example of one of the industry which starts making the speedometers of the car. Here on the right hand side, you can see this is the assembly line where different components of the car are being assembled together. So in all of these, if the parts are assembled properly, by looking into the desired key features of the assembly function, so the product will obviously perform at its best level. If I give you example, I'm sorry to say, quote it, कि आपने देखा होगा पाकिस्तान के अंदर, within Pakistan, there are some automobile companies, and for the same company, we also get the cars which are being imported cars. वही Japanese assembled car पाकिस्तान में आए, एक कोई भी brand, मैं brand का नाम नहीं लेना चाह रहा, I don't want to take the name of the brand. And at the same brand, if it is being assembled in Pakistan, and I'm sorry that because of lack of skills or negligence of the worker, they do not properly look into the assembly parameters, you find the quality of the car, quality of drive, quality of comfort within that particular car. A car which is been imported from Japan and it's assembled over there, by looking into all the particular features of particular assembly design, you feel lot of difference in the quality of that product. And this is only because the assembly parameters are not taken into the account properly. Now let me start giving you basic modeling of assembly through the example of a very common example of a stapler. I think you all are very well aware of the stapler. The function of this stapler is to pierce the pins, staples, into a bunch of papers so that the papers are connected together. So this is what the basic function of the stapler. Now, if you look into the stapler design, stapler contains three basic sub-assemblies. The first assembly is the handle, which contains the hammer at the edge. एक छोटी सी plate होती है, and that is actually you can see showing you the small hammer. Then it has the carrier which carries the staple carrier, and then we have a base, and this base has the anvil part, and which have at this particular location crimper is attached, which bends the staples so that the papers are properly connected and integrated together. Now, if you see here, ये मीटिंग का एंड का ऑप्शन आ रहा है, अगर इसको ठीक है. Now, if you see during this stapler, अक्सर हमने देखा होगा कि stapler हम मार्केट से परचेज कर रहे होते हैं and we just find sometimes the stapler is working fine. और by the way, अगर ये नीचे गिर गया तो कुछ अरसे के बाद वो stapler properly pins staple नहीं कर पाता. So it cannot staple. Sometimes the staple is stuck inside the page or they stuck within the stapler. Now, what is the reason within this small assembled product? We first of all see the complexity of this product. Now, what is the function of this stapler? It staples the pins. That is the function. But for the desired function, what are the parameters should be taken in consideration into this particular stapler? What we see that the stapler hammer, यहाँ पे जो plate लगी होती है hammer, this hammer should be perfectly aligned with the passage from where the staple should come out of this carrier, and this should be perfectly aligned with small crimper anvil. Okay, if these three things are not aligned properly while it moves downward, so obviously either the pins will stuck or they will not perform its function properly. The second parameter for this is that this hammer should be perfectly straight, perpendicular to the surface. It should be perfectly straight. कोई इसमें टेढ़ापन ना हो, थोड़ी भी टेढ़ी हो जाएगी तो it will push more than one pins. And the thickness of this hammer should be less than the thickness of the staple pin. Okay, its thickness should be less than the thickness of the staple pin. Why? Because if the thickness is greater, it will not push one pin. It may push two pins or more than that. So obviously, the hammer should be having thickness less than the thickness of the staple pin, and it should be perfectly straight aligned with the staple. Then and then it will be able to perform its function properly. Now, looking at this very small, simple assembly, we see little complexity. अक्सर स्टेपलर गिर गया, उसके जो हैमर है वो थोड़ा टेढ़ा हो गया. If it bends, if it has been distorted, it won't perform the function at all. So what we do, we just simply throw it. But मेरे पास अक्सर स्टेपलर कोई बंदा लेके आता है, मैं उसकी जो है ये हैमर उसको हाथ से प्लास से स्ट्रेट करके I just simply reuse it because I know how to fix it, and that is how we need to look into these particular things. So here, these are the main issues that in this, what we see that for such type of assembly where the function is mainly dependent on the assembly key characteristic, we say the key characteristic. And what is that key characteristic? How do we define it? The key characteristic is basically the measurable design variable, on which if we do not satisfy that design variable, the its performance will be highly affected. It won't perform its desired function. So in high precision complex product, there is a need to satisfy precisely design variable to product quality and performance. Now, in assembly, the main issues are that the accuracy in assembly modeling and considering the geometric tolerances, better prediction of assembly tolerance, and controlling assembly variation propagation. We'll discuss these all in the upcoming slide. Let me take the example of this. Admin जो है आप कर दें.
मामा यार आप लोग चुप नहीं कर रहे हैं.
म्यूट कर दीजिएगा अपना माइक. डॉक्टर साहब, एक अनाउंसमेंट ये भी है कि ये सेशन जो है वो एंड होने जा रहा है. 5 मिनट है. इन केस ये सेशन एंड होता है तो उसी लिंक पे तमाम पार्टिसिपेंट उसी लिंक को ज्वाइन करें और दोबारा इस सेशन को कंटिन्यू कर लीजिएगा. ठीक है, थैंक यू. ठीक है जी, डॉक्टर साहब कंटिन्यू करें.
इफ यू टेक दिस एग्जांपल ऑफ दिस प्लेन, within this plane you can see the engines made up by the CFM International, and these are made by General Electric and Safran. and the wings are made by AVIC company. And again, if you see, there are different companies making different products. Koi America se, koi China se, koi Germany se, kuch product yani mukhtalif locations se aa rahe hain. So the tail AVIC is again from AVIC company. Okay, so these different parts are being produced in different countries at different companies, and then they are brought together under one roof, and they are combined so that they can easily be assembled under one umbrella. So in this particular case, what we see, before going into depth, okay, for looking at this example, we see the tolerance limits, tolerances or geometric variations within the component. Whenever any part is being produced, it is manufactured, we say nothing is manufactured perfectly to its design specification. कोई भी चीज आप बनाएं तो कभी भी perfect design नहीं हो सकती. Perfect सिर्फ अल्लाह की जात है. So obviously there are certain manufacturing errors which are inherent because of the manufacturing process, but we allow some certain variations. Those are called to be the tolerance or the geometric variations. Now let us first look into the geometric variations, which play a major role in the accumulation of error of the final product. हर part के अंदर कुछ error है. जब हम 1000 parts assemble करेंगे तो assemble करने के बाद वो सारी errors accumulate हो जाएंगी, and add up होने के बाद कुछ वो ज़्यादा error हो सकती हैं. So we need to avoid these all type of errors. So let us see briefly. मैं सारी geometric errors को कुछ classify किया है. Form और profile error, जिसमें line profile, surface profile, इसमें flatness आ गई, centricity आ गई, और straightness, roundness. फिर दो surface आपस में parallel हों, वो भी एक होना चाहिए. And location error, coaxiality, symmetry, runout variations. और runout के अंदर जो है circular runout, total runout and axial runouts वगैरह होते हैं. Looking into the example of axially symmetric component, क्योंकि jet engine के अंदर जो components वो axially symmetric हैं. Now let me define what is axially symmetric. वो component, अगर आप ये देखें cylinder, this is what cylinder. If you look at the cylinder from either side, अगर आप front से देखें तभी आपको इस तरह से दिखाई देगा. इस एंगल से कोई बंदा देखे उसको भी सिलेंडर इसी तरह से दिखाई देगा. किसी भी एंगल से देखें ये सिमेट्रिक है. That's why we call this such type of object as axially symmetric, जो हर एक्सिस के अराउंड हर साइड से सिमेट्रिकली प्रोड्यूस किया गया है. So this is what called to be axially symmetric part. And in rotating machines, any machine which is rotating component, the rotating parts should always be symmetric, so that they can run at higher speeds in order to avoid any particular vibration. So आप कोई भी rotating machine देख रहे हैं उसमें जो parts हैं वो axially. So in this, if you see, we just normally take into consideration the errors, geometric errors. यहाँ पे ये देखें कि ये circularity error है, और हम इसको रन आउट के पैरामीटर लेते हैं. रन आउट दोनों को लेता है, एक को कंसेंट्रिसिटी और सर्कुलरिटी एरर, दोनों की कॉम्बिनेशन. एडमिन आप अगर अपनी उससे माइक्स ऑफ कर लें.
डॉक्टर साहब इस वक्त एडमिन आप हैं, अगर मुमकिन है तो आप काइंडली.
बिलाल म्यूट करो.
ये बड़े लोग ना मुझसे ज्यादा लोग होते हैं, इनसे दो घंटे मुनासिब हो रहा है, क्या है और चले जाएंगे. बहुत और ये था ये आप
ठीक है. Now if you see here again that whenever we see that the objects, ये ideal इसका shape you can see over here कि ideally the object should be cylinder, but हमने अगर इसको measure किया इसकी actual diameter